Okay, we're going to continue with homework 10 notes. We've been talking about parallel and perpendicular lines. Things you have to know is parallel lines have equal slopes, meaning they're the same. Perpendicular lines have negative reciprocals. I call them opposite reciprocals. And so if we were given the slope of our original line was m equals negative 3/8, if we were writing a line parallel to it, we'd use the same slope. If it's perpendicular, the opposite of a negative is a positive, and the reciprocal is 8/3. So you just flip it. Okay, so in example 2, it said give an equation of slope-intercept form, equation of a line in slope-intercept form that passes through this point and is parallel to the line defined by this. Well, because it's parallel, we know they have the same slope. Well, over here, this is in y-intercept form, or slope-intercept form. So this is in mx plus b, so our slope is 3. And because we're writing an equation parallel to it, we're going to use m equals 3 as our slope. Then we just plug in a point slope with our slope and our point, and then solve for y. Down here, it says give the equation in slope-intercept form that passes through this point and is perpendicular. Well, what do we know about their slopes? They're opposite reciprocals. So it's perpendicular to the line defined by this. Well, the problem is we don't know the slope of it. We've got to get it in slope-intercept form. So we're going to take that 5x to the other side by subtracting it. And we have 2y equals negative 5x plus 10. Now we're going to divide everything you see by 2. And we have y equals negative 5 halves x plus 5. Okay, so the slope, the reason we're doing this, oops, sorry, you couldn't see it. The reason we're doing this is so that we now know that the slope of this line is negative 5/2. But the line we're trying to find is a line that's perpendicular to this. So if it's perpendicular, we're going to do the opposite reciprocal, or the negative reciprocal. So the opposite of a negative is a positive, and the reciprocal is being 2/5. Now, we're not going to use this anymore. The only reason we did that is to find the slope. Now, we use this information, these two things. Plug it into point slope or slope-intercept form, however you want to do it. I don't care. Y minus our 8 equals 2/5 times x minus 6. Now step 3, solve for y. Y minus 8 equals 2/5 times x is 2/5 x, and 2/5 times a negative 6 is negative 12/5. Now we're going to add 8. That goes away. Y equals 2/5 x plus, I think that's 40/5, so it's going to give us 28/5. Okay. What I'm doing here is negative 12/5 plus 8 is the same thing as 40/5. And then I got 28. Or you can do this, however it is that you want to do. If you have the fraction button, if not, you can just use division. You have negative 12, it doesn't really matter where your negative goes, plus alpha f1, 1, and you get 40/5. Then you get 28/5. If you don't have the fraction key, you say, I like to put my fractions in parentheses, negative 12 divided by 5 plus And you can just do plus 8. I didn't really have to do this. I meant to just do up here, this part right here, but I'll do that in a minute. Plus 8. I'm going to hit math fraction. There you go. Now, I didn't mean really to do this. And I still get 28 over 5. Okay, so, there you go. Alright, so remember, parallel lines, same slope. Perpendicular lines, opposite reciprocal. Alright, the next one, the back side of it. We're going to talk about linear regression. Basically, it is, we're going to let our calculator give us the line of best fit. Linear regression is line of best fit too. So we've got all these scores right here in what's called a scatter plot. It just has a bunch of points. And then we draw a line through the middle. And that's the best fit. So we graph the data in a scatter plot, which we're going to learn on our calculator in just a minute. We're going to inspect the data visually and determine if the data suggests a linear trend. This does. They all kind of fall within that line. Invoke the linear regression feature on our calculator, graphing utility or spreadsheet. We're going to do it on our calculator. And we're going to check the result by graphing the line with the data points to verify that the line passes through or near the data points. Alright, so in this particular case, we're not going to do this on our calculator. There, it says they've already done it for us, and they've found us the equation of the line. The scatter plot shows the time spent studying X. So right here, this is the number of hours a person or a student studied for their midterm. And it's correlated to what they got on their midterm. Okay, for 23 students. So it shows the time spent studying, which is X, and the midterm score, which is Y, for 23 students. The line of best fit is drawn for you. Okay, use the equation of the line of best fit, Y equals 3.83X plus 15.68. To answer the questions below, give the exact answers, not rounded approximation. This means use the equation above, not the graph shown. So we're going to use this here. What is the predicted midterm score for a student who studies 15 hours? Remember, this is our hours. This, our Y, is our score. So all we have to do is plug 15 in. Y equals 3.83 times 15 plus 15.68. So take our handy dandy calculator. 3.83 times 15 plus 15.68. So we would expect this person to receive a 73.13, a score of that, okay, on their midterm. What is a predicted midterm score for a student who doesn't spend any time studying? Well, you plug in 0. Y equals 3.83 times 0 plus the 15.68. That gives a 0, so this particular person, you can expect to get a 15.68 on your midterm if you don't study. Alright, for an increase of 1 hour in time spent studying, what is the predicted increase in the midterm score? Well, the increase is for every hour. That's the same thing as our slope. So for every hour that we spend studying, it increases by 3.83 points. Because that is our average rate of change. for our slope is the same thing. We talked about that yesterday, or I guess Monday now, seeing it is 1 o'clock in the morning on Wednesday morning. So on Monday we talked about average rate of change. Here's just a little thing. It says watch the wording in ALEKS. Predicted increase, decrease, and change are slightly different. For example, y equals negative 2.4x plus 5 is a predicted decrease, and that's because that's negative. Okay? All right. Now, this is posted. Okay? You do not have to print this out. You really don't need it if you just take your own notes on your own paper. So what we're going to do is we're going to learn how to use our calculator. They'll give you this information here, and they'll have a scatter plot. This is just these points graphed. Well, there's a line of best fit between these, and that's what we're going to try to find. So, and it's called linear regression, creating a linear regression model, which is also called the line of best fit. Notice what this says. This skill is in ALEKS in the quizzes, but not in the homework. This skill may be tested. I can tell you right now, it's going to be on your test. So you need to know how to do this. Some of you have already learned this if you've taken stats before. So, steps for using the TI-83 and the 84 to calculate the line of best fit. First of all, we're going to enter the data into the stat editor. That is stat enter. So here's what we're going to do. On your calculator, here is the stat button. So when you hit that, let's see if I can get it where the glare isn't. This is what comes up. So we are going to hit stat, then we're going to hit enter or 1 because it's under edit. So I hit 1, but it doesn't matter if you hit enter because it's highlighted. Now, I have some things in here because I was practicing the problems that are on these worksheets. If you have things in here, okay, to clear them, take your arrow up to the top where the L2, this is list 2, this is list 1, and now that it's highlighted, hit clear, just your clear button, and hit enter, and they disappear. Use your left arrow key, go up to L1, hit clear, hit enter, and it clears them out. Okay, so the buttons we're using is stat and then 1 or enter because we're going to edit. And then what we do is we list our X values here. Oops, it's got that glare, sorry. We would list our X values here and our Y here. Okay, so that's where we're at right here. These are just the instructions. Then in the stat menu, so we go back to stat, you'd go over to calculate, and we'd hit 4 for linear regression. Okay, when you do that, depending on your calculator, if it's a newer calculator, it'll look like this. You hit enter until it calculates. Okay, so as you may see the menu to the right, that's what this one looks like. You're just going to press enter until it calculates. You might see these words here. If you do, hit enter, and then you'll see this. Okay, so you will then see the screen similar to this. You may or may not see the 2 rows with R's. You do not have to worry about these because we don't use them in this class anyway. Then you're going to use your A for your slope and your B for your y-intercept. All right. Now let's see. Let's look at this first example. Okay, so when I learned my calculator, I like to take my own notes. So the first thing we're going to do is we're going to hit our stat button. And when you do that, stat is right here. When you hit it, this comes up. So we're going to I'm just going to hit 1. If you wanted to hit enter, that's fine, because we need edit. Now, we are going to put our X values under L1 and our Y values under L2, under our second list. Okay? So, here I do my X's first, then I do my Y's, because I can do it faster. I'm going to hit 0, make sure that it's on this first line that's highlighted, hit enter, drops it down, 1, enter 2, enter 3, enter 4, enter 5, enter 6. I'm going all the way to 8. So I have the numbers 0 through 8. I'm going to use my right arrow key. It takes it over to the second list. And now I'm going to enter my Y values. 0.5, enter, 1.3, 2.9, 2.4, then 4, and periodically you might want to check, is 4, 4, are we on the right line? Yeah, because sometimes you'll skip a number accidentally. 5, 5.4, 7.7, and 8.3. Alright, so we've got our X and our Y's in there. So here's what you want to do. Now, you want to hit your stat button again. And when you hit your stat button, you want to use your right arrow key to go over to calculate. Just put my right arrow key. Okay, and by doing that, it highlights calc, but we want to calculate linear regression. We want to calculate linear regression, so I'm going to hit the number 4. You can arrow down to 4 so it's highlighted and hit enter if you want to. But I'm going to hit 4. And because mine looks like this, I'm going to hit enter until it calculates. So me, it's 1, 2, 3, 4, 5. And it comes up with this. Sorry, I cannot. There's a glare. Okay. Now, if yours didn't come up with that, in our directions, you might see this. And then you just press enter. And you're just going to have, then it's going to give you this. Okay? All right. So either way, it now gives us our formulas. Y equals, let's see if we can see it over here. And you have to pay attention to your instructions. This one says 3 decimal places. So 0.967 x plus 0.3. And that's our line of best fit between those points. Okay. All right. Next problem. All right, just two more problems that we're going to practice. Now these are kind of, it's not as blurry as I thought it was going to be. I just couldn't get it scanned. My phone, for some reason, it'll scan, but it won't email for whatever reason. I don't know why. Okay, so following table gives you the wind speed of a hurricane versus the barometric pressure. Okay, the wind speed is Y, the pressure is X. Use the data in the table to find the least square regressions. Round the slope to 2 decimal places. And the y-intercept to the nearest whole number, or whole unit. Okay, so we have to get this in our list. This under L1, this under L2. So how do we do that? We hit stat. When you hit stat, this comes up. We're going to edit. Wish I could, there we go. I put my hand over the light. I have a light over my desk and it's putting a glare on it. So I'm going to hit 1. Now I have all these things in here. I'm just going to have to move it. I need to clear them out. Use your up arrow key, hit clear, enter, clears it out. Go over to L1, hit up, hit clear, hit enter, and it clears it out. I'm going to plug all this into L1. I know I'm doing it kind of fast, but you can pause the video. 1007, enter 1003, 1000, 994, 983, 968, 950, 930, and 905. Now, I will tell you this. If you are doing this in ALEKS and you get it wrong, you might want to just, the first thing you need to check is to make sure you plugged in the numbers right. Because sometimes, like on this problem here, you might have put 99 instead of 994. So, okay, now I'm going to plug in these values under my L2. I have 35, 45, 50, 65, 80, 100, 110, 145, and 160. Oops, see, I put 106 instead of 160. So I need to change that. I'm just going to highlight it, and type over it, and hit enter. It's not a bad idea if you check your numbers, okay? So, anyway, what I'm going to do is, oops, well, I'm not done. Okay, so we've got our numbers in there. Now what we have to do is hit stat again. We need it to calculate, so we're going to use our right arrow key. We want it to calculate our linear regression, so we're going to hit 4. I'm going to hit enter until it calculates. This is my slope. This is my y-intercept. Be careful to pay attention to your instructions. Your instructions say to round your slope to 2 decimal places, so it's 1.22x. Your y-intercept to the nearest whole unit, so it's plus 1,273. And there's the line of best fit for these values. Okay, this one right here. Okay, so this one we're going to do the line of best fit, then we're going to predict the height of an 11-year-old girl. Alright, so in the table, give the average height, y, in inches for the girls, age x in years. Write the equation of a line of best fit for the data given in the table. Use 3 decimal places. Okay, hit stat. 1 for edit. Let's clear out. Go up, highlight L2, hit clear, hit enter. Go over, go up to L1, hit clear, hit enter. Now let's do ages 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I just wanted to make sure they didn't skip an age. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did not skip anything. Now over here, I'm just going to put 35. I think if I put 35.00, it's going to change it to 35 anyway. 38.50, 41.75, 44, 46, 48, 50.5 or 50.50, 53, and 56. I always like to check to make sure I have, like if I've got 9 over here, I have 9 values over here. Okay. Now I need the line of best fit. I hit stat. I use my right arrow key to go over to calculate. And I go down to linear regression, or I just hit the number 4. Enter, 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 enter. Here's my slope. Here's my y-intercept. My instructions say to 3 decimal places. So it's y equals 2.483x plus 30.961. Okay, so that's the line of best fit. Well, we now want to predict the height of an 11-year-old girl. Well, remember, x is our age. So I'm going to plug in 11 there. 2.83 times 11 plus 30.961. So now to get off of the screen here, okay, to go back to what I call our home screen, you want to quit. It's in blue or yellow on your calculator, so just hit second and then hit quit. This takes us back to the screen where you add, subtract, multiply, and divide, or what we call our home screen. Home screen, I can't talk. 2.483 times 11 plus 30.961. And now we hit enter. And I would say it had to be in 2 decimal places because all of these are. So the 11-year-old girl would be 58.27 inches. And that's it.